Find the domain of h of t equals t over the square root of t plus 1. There are two things happening here that are going to affect our domain. Number one, we are doing a division here. And if you're dividing by something, we know we can't divide by 0. Second is that we are doing a square root. And we know if I'm doing a square root of something, I'm not allowed to do square roots of negatives. So we're going to take those two things. We'll start with the division. We are dividing by the square root of t plus 1. So the square root of t plus 1, the thing we're dividing by, cannot equal 0. And now we need to get t by itself. So if I square both sides, then I get t plus 1 cannot equal 0. And then subtract 1 from both sides and get t cannot equal negative 1. So that's the first restriction that I have just because I'm dividing. The second restriction comes from the fact that I'm doing a square root. And when I'm doing a square root, the thing I'm doing the square root of, which is t plus 1 in this case, has to be greater than or equal to 0. And so to get t by itself, I can just subtract 1 from both sides, and I get t is greater than or equal to negative 1. These are the two rules that have to be true. T cannot equal negative 1, and t has to be greater than or equal to negative 1. Those are what I have to adhere to. Now, when you've got multiple rules, it can be hard to put them all together and find out what's okay. This one's not too hard, but I'm going to show you a process that I like to follow. And that's if I just draw a little picture of a number line and draw these two rules separately. Okay, so my rule t cannot equal negative 1. I'm just going to indicate here at negative 1. This means I could be anything but negative 1. So I've got a hole there, and I can be to the left or to the right forever. Okay, so t cannot equal negative 1. This is a visual representation of that requirement. The other rule, that t has to be greater than or equal to negative 1, means that I could be negative 1, that would be filled in there, and t can be greater than that, so I could go to the right. Okay, and the domain, when I find the domain of this function, I need the overlap. I need every rule represented, every color represented. Okay, so as I move to the left, I don't have blue over here. So I know my domain is not going to include any of this. Okay, so I can cross that out. Cannot be that. Okay, I get to negative 1, and though blue is included at negative 1, red is not included at negative 1. So I can't be that as well. After that, however, I do have both colors. And so my domain is everything from negative 1, exclusive, meaning I don't include negative 1, all the way up to infinity. So my domain in interval notation is negative 1 with a parentheses, meaning I can't be negative 1, to infinity. This is my interval notation for the domain, or I could do set builder notation, which is the set of all x that are real, such that, and then x would have to be greater than, oh, I'm sorry, I'm not doing x values, I'm doing t values. Let's make sure we stay consistent with that. Our t values, t that are real, such that t is greater than negative 1.